VLPSos here. This is a video for Python programming animation. I've started with the stub0 file. I've made a couple of changes. I changed the caption to the name of this lesson, and I've added 3 colors. The colors that I'm going to use are white, black, and light blue. Light blue is set as 100 red, 100 green, 180 blue. Doesn't matter what the color is, but we're going to use those 3 colors in this program. The first thing we're going to do is create something that we will then animate. We're just going to create a square, and we're going to have that square move. We could draw a square as a rectangle that has an equal width and height, but I'm going to be a little more sophisticated. I'm going to go in the direction that we want to be in the habit of when creating animation and programs. We want to make a class and then create instances of that class, which will then be the objects that we manipulate, animate, move, or use. So even though in this program I'm going to create one block to animate, I'm still going to create a class to create and manage that block. So we're going to define the init function. And the block will have a unique attribute called color, but it will have many attributes that we'll define here. If it's going to be animated, we're going to create an attribute called H direction, H for horizontal. So this is going to be an example of a block that gets created. It's going to be a square, and then it's going to move horizontally, at least in one direction at first. So we'll set that direction to be the string right. We'll also need a speed to control how fast it will move. Point 2 I've discovered on my computer is sufficient. That speed could be adjusted depending on the processing speeds on the computers that you're using. It'll need to be adjusted or be different than point 2, but point 2 is a good starting point. Size will be used for the height and the width of the block, which is going to be a square when it's drawn in 2 dimensions. X position is then the position of that block, and it'll start at 30, and Y position is the other part of the coordinate to position that block, and it'll be start at 100. And we need to make use of that color that was passed in the argument. So there we have a class structure to create a block. Let's now make an instance of that block. Before the frame loop begins in the code, which is what accomplishes animation by giving that illusion of very quickly showing still compositions that might change very fast. Before we start that process, the frame loop, the while loop, I'm going to make a comment here, which is a very good place to make instances of the things that you might want for your program. In this case, we need to make a block, and we will use a dictionary to contain, even though there's only one. It's a good habit to be in, to use a dictionary to contain your instances. We're going to make the block that goes in the, we're going to call the dictionary blocks, goes in the dictionary of blocks with a key of 0, and it will be equal to a call to the class block, and we need to send it a color. We've predefined colors white, black, and light blue. We're going to make this block light blue, which will become the color, or we'll use that as the color of what we draw. Okay, now that we have a block created and it's located in the dictionary, we're going to save and run our code, mostly to debug anything that might have come up. And indeed, we have an attribute error. Block has no attribute color. That's a mistake. Let's check. Oh, it's because we didn't assign it to be equal to the color that came through. So I found that error, corrected it. Let's check again. Save and run. And we have no errors that come up, and a black rectangle, which is our screen surface that we're going to make use of. As exiting idle, we'll close both idle and the graphic screen down. Now I'm going to make a comment for drawing the block. And there could be more than one, even though I won't make more than one. The program will be capable of drawing several if we wanted it to. And the place that we're going to draw the blocks in the frame loop, this is part of the code now that's part of the frame loop or the while loop, is going to come before updating the graphics display, because we're going to have something, we're going to make a change to the screen, and which is the drawing of the block. And then we want the user to see by afterwards running this line of code, which is part of our stub. And then the very last thing is to process the event queue. These lines of code that have yet to serve some purpose other than just being there in order to process the possibility that the user could be pressing keys or moving the mouse, so it doesn't freeze up our program, our graphics program. Those lines need to be there. So what does it mean to draw a block? Well, we're going to iterate through the dictionary. For key in the dictionary of blocks, we're going to draw a square by using the attributes of the instance that we created. So it's going to be a call to pygame.draw.rect for rectangle, and the argument for rectangle is screen and then the color of the rectangle. Now the color is an attribute that belongs in the dictionary of blocks. The only one we have has a key of 0, and then we dot color as the attribute for the color. The next thing in the argument is the position, which is a tuple of 2. And the position of this block is based on the attributes. Again, blocks with the key 0. The X position comes first. We'll use a comma and a line break, and I could copy this and paste it, because the only thing that changes is that Y to complete the tuple of 2, which is the position, the X and Y position on the screen that the upper left corner of this rectangle will be located. I'm going to put a line break here so that my line doesn't go off the screen. Now, after getting the position of the rectangle, we need the height and width. Well, the convention we're going to use is going to put that inside the tuple. So it's going to be a tuple of 4, where the first two things are the positions, the X and Y position, and the next two things are the width and height. Both those come from the attribute size. So we access the width as the size attribute of that block, and then a comma and the height, which is also the size attribute. So this is going to be a square. The width and height are both size, therefore they're both equal. Now that that tuple of 4 is finished, we're going to supply the line thickness, and we're going to have this block filled in with a line thickness of 0. Let's see if it created a light blue block. Without error, we got an error, has no attribute X position. Let's check. Here's where it's asking for it. And I said X underscore position, checking the spelling. Putting an I into it is what I needed to do. And somehow we got a paste there. Key was pressed, so somehow I think it was the copy that didn't work. So I'm struggling to blocks with key 0. I'm not afraid to go through these things on camera because coding mistakes and syntax error and spelling mistakes are very common. So this being a part of the lesson is showing students that it happens to me too, all the time in fact. Let's see if I got it right this time. I do have a purple, lightish blue square, which is a rectangle that's been drawn on my screen there. And of course it's not animating. Animating would be moving its position and doing it a little bit each frame or each time the while loop iterates, and then the position would seem to be changing, and it would give the illusion of the block moving. So let's do that. Before it's drawn, I'm going to make a comment, make some space, and make a comment for moving the blocks. How many of I have? I only have one that I'm working with now. So what does it mean to move the block? We're going to do that before we draw it, and then do both of those things before we update the display to show the user. So moving the blocks is, we're going to iterate through the dictionary again. Moving the blocks is changing the position. There are two variables for the position, x and y. So if we wanted to move to the right, then we would add to x. X is the horizontal variable. Increasing x would move the position to the right on the screen. But we also have an attribute called the h direction, the horizontal direction. So it's been set as right, but we're going to change the coordinates of the x position based on that h direction. To do that, we simply need a condition. So we say if, and then refer to the attribute, the h position attribute of that instance in the dictionary of blocks. If it is equal to right, then what we're going to do is we are going to modify the x position of that block. So again, referring to the attributes in blocks dot x position, but we didn't want to refer to the position. We wanted the direction to be equal to right. We're checking the direction. If it is right, then the position attribute is going to be changed. We're going to add a little bit to it. But we've created an attribute called speed. So here is the time to use that speed. The h position is going to be increased by the amount of the speed. So if we have a higher speed value, then we'll be changing that x position by a higher value. We'll be changing it more. It'll appear to go faster. Again, we need to refer to the attribute in blocks with key 0, the speed. Let's take a look. Save and run. We have some motion, but what happened? We have an error that was a warning. There's a reason for that, though Python is kind and let us get away with it. The effect of our attempt to move the block was to create an ever elongating rectangle, it seemed. Let's see that again. It was a block that smeared. That was anticipated, and here's what's going on. We have a screen that was all black, and we drew a square. We're calling that a block onto the screen at a certain position. Now we did successfully change the block's position so it was drawn in a new position. And then it did that every frame. The frames went by quite quickly, so we saw that quickly draw out. But we didn't see it as a block independent of all of the times that it was drawn before. In other words, it kept on drawing a block on top of all the blocks that it had drawn before. So how do we get rid of the drawing of the previous blocks? We need to have our screen start over. We need to erase the drawings or the drawings of the previous blocks. Erasing doesn't exist in Python programming. What we mean by erase in this case is to start with a fresh screen that is black. In other words, we want to fill our screen with black again so that the new position of the block can be drawn and that's all we see. So at the very top of the frame loop, we're going to fill the screen with black. This has the effect of erasing, but we don't really erase. We just start over with a fresh black screen. Let's see if that works. Well, I forgot the fill function. Now this is using the fill function on the screen, and the argument of fill is the color that was previously defined as black. And we can see that that square now is traveling, and it seems to be by itself moving across the screen. Okay. Well, why does it leave the screen? Because the position keeps changing and x keeps increasing to the point that we're locating it at an x position that is not on the screen. It's got a greater x value than the width of the screen. So it leaves, it doesn't break our program, but it's being drawn in a location that we won't be able to see. The computer remembers the location even if it can't be seen on the screen. It would be more interesting if when the block hit the edge of the screen, it came back, almost to bounce. And we can do that by testing the position. After we move it, we can test whether the block needs to now move in a different manner because it's reached a certain part. And this is part of what we call collision. So we're going to make a comment, and after we move, test for collision. And I'm going to capitalize collision because it's an important concept in animation. We're going to iterate through our blocks again, even though we only have one. And we're going to think, well, what does it mean for the block to reach the edge of the screen? A block has a position and the screen has a width. If the block gets to be the width of the screen, its x position is the width of the screen or maybe even greater, then it has reached the edge of the screen or gone over. So that's a simple condition to make. We want to see if the block's x position is greater than or equal to the screen width. Well, that's going to happen at some point when the block moves over there. But what happens if that's the case? Well, we have this horizontal direction attribute. Why don't we say it's going to now change direction? It's going to go to the left. Well, we can do that. Block's H direction attribute is now reassigned to be left, a description of the movement that we would like to see. So the block's position, if it changes and gets to be ever greater than the screen width or equal to it, then the direction changes. But I thought the direction was going to change. Now, of course, it did, but that's only left is not a description that automatically works. We now have to code for what it means to have a direction that is left instead of right. This condition right here is only when the block's direction is right. So in the move the blocks, we could write an else condition. If there's only right and left values for this attribute, then if it's not right, it's going to be left, and we don't have to say whether it's left or not. So this is, if the H direction is not right, it's going to be left. What do we want to do? Well, we want to do something very similar. We want to copy and paste this because the X position attribute is going to change, but it's going to be lessened instead of, we're going to subtract from the position instead of add to it. Subtracting from the X position, which means it's going to get closer or go in the negative direction, which is to the left. Let's see that work. Gets the edge of the screen and seems to bounce. But wait a minute, it went off the screen in the other direction. Well, we can make it bounce off or look like it's bouncing off of the left side of the screen with a similar strategy. So we're going to test for collision when the block becomes less than or equal to the left edge of the screen, which is a horizontal position of 0. So we could test then the condition, and it's going to be very similar to this code, so we can copy it and paste it. But what we want is if the position is less than or equal to, not the screen width, but just 0. And if that's the case, then we want it to go right. Reaches the screen width, and then reaches the 0 point of the screen, left side of the screen. Now notice that the bouncing doesn't seem to be in the same manner. It seems to bounce off the edge of the block when it's moving to the left, but when it's moving to the right, it goes off the screen by the block's width before it bounces. Well, we can adjust for that to make it look a little bit better. In the collision with the edge of the screen, which is right here, we want to mathematically modify it so that it's not the position of the block, which is the top left corner, that has to become greater than or equal to the screen width. But we want that position to get as close as its width. So we want to account for the position, which is the top left corner, plus its width getting to be at the edge of the screen. So we're going to modify this by mathematically adding the width of the block, which is the size attribute, so that the sum of its position and size needs to reach the edge of the screen before it becomes or goes to the left. Now it seems to literally bounce off the sides of the block, and that kind of animation and bouncing looks more realistic. It looks more interesting. Now there's something that is not happening in this example, which very often does. And so even though it's not happening, this common effect of the block or the object that you're moving when you want it to bounce kind of getting stuck and seeming to vibrate and get stuck on a side is a very common thing to happen, and may happen to you. So we're going to include the fix for that in this code, even though it's unnecessary here, probably because the speed of this computer is sufficient enough that the math is not trapping the block. And that is to include in these collisions the fact that before you test for whether it's reached the screen width, you also want to include in the condition that the block is moving to the left. So this condition here is going to be compounded. We're going to put parentheses around this because this is one part of the condition. We want to write an and, because we want to also, if you're going to be moving, if you're going to bounce on the right side of the screen, you also want to make sure that you're also moving to the left. So you're moving to the left and you're reaching that edge of the screen. This error that happens quite frequently is if you reach the edge of the screen and you seem to bounce, but you don't bounce back far enough and your position is still at the edge of the screen, then it could change the motion again and there could be some confusion. It's not happening here, but add this and think about adding it, that you also want the direction to be going right before you bounce, and then it will switch left. Compound condition, H direction is equal to right. And I'm going to copy this and include it in this condition as well to make it a compound position. To bounce off the left side of the screen, we want to make sure that we reach the left side of the screen while we are moving to the left. So in this case, we add if the block's position is less than or equal to 0, x position, and the direction of movement was left when you're detecting this. That will save from some pretty peculiar graphic errors that happen very commonly. Let's take a look at what we got. We have an animated block that's bouncing. Now let's take a look at this, which is a warning and not an error. Python is very kind, and it's telling us that when we are drawing something, when this function to draw a rectangle has been used, and we have a position that is not an integer, then the program shouldn't make sense of that, because there's no fractions of pixels, and the location of something that's drawn or placed in graphics is always at a pixel location. There's no such thing as a pixel location of 10.5, because there's no number 10.5 pixel. There's pixel number 10 horizontally, and then pixel position 11, and nothing in between. Pixels are the smallest amount of screen space that we can be using. Now Python is kind because it's allowing us to have coordinates, pixel coordinates, that are floats, that include fractional components, but still deal with them as if they're integers. And it's giving this warning that we should be using integers, and it's patching it over and not breaking our program. Now we can get rid of that warning and get in a very good habit of when we want to use something as a position, as a pixel position, then we make our position values integers at the moment that we use them. We put them into the integer function. So here in the drawing the blocks, this part of the argument is where the position of that block is going to be drawn. It has an x and a y position. I'm putting those components into the integer function. Now it doesn't change their value to become integers. It just uses the integer form of that value, and that value is a float. So it converts it to an integer and then uses it as a pixel location. Let's see if that warning comes up. We get our animation. The block is being drawn at pixel locations. And we don't get the warning saying you're using floats, we'll deal with that, but we just want you to say you should be making them integers before you use them. Now, why are those locations integers, or not integers? Why are they floats, and why do we want them to be? It's because of our speed. We started with a integer location 3100. That's 30x and then 100 down, because y values come down from the top. Well, that's what we started with, but every frame we added the speed to that x value. The x position of 30 in the next frame became 30.2. And the reason why we wanted the speed to be a float is because having a speed, even of the smallest amount of pixels, if it was just the integer 1, so we are always at integer values, 30, 31, 32, then check out what would happen to the speed of our animation. Very fast, maybe too fast, though you might want some things to move this fast with a speed like that, not so much. So using small float values for speed is common, which means that the positions of things are almost always going to be floats, though they have to be converted to integers at the moment that you use them. And that's how you do it. You don't make the attribute an integer, you just use the integer value or the integer approximation at the point that you need it to be an integer. This is something that is very common to do. Try to remember to do it every time you program like this. Now You have seen how animation is accomplished by changing the position of something that is drawn on the screen every frame. And also remember to erase your screen by filling it or making your background, refreshing your background of your screen, or else you'll get what's called a smear of the object. Take this code file and add to it by allowing the block to also change its vertical position and bounce off the top and bottom edges of the screen. So horizontal animation and bouncing has been done. Add vertical. Don't go purely vertical. Keep the horizontal and add vertical so it's going to bounce all over in 2 dimensions. It's recommended that you change nothing about the horizontal animation that is already working. Just add new attributes to the class like V direction, V for vertical, and add blocks of code under move and collision that work like the ones of the horizontal effect. But keep the horizontal effects that are happening, and you will enhance this program.